Okay, this is our code running on the FPGA, and we can divide our demo video in 7 parts. This is the first part. This is the screen that before the game starts. So we can see that there is a Go display on the screen, and the green block is moving horizontally on the screen. The second part is how to start by pressing the button in the middle, which is N17. The Go disappears, and the green blocks start to have a vertical speed, and that means the game starts. And the third part is a basic playing method of our game, and let's start the game. Now the green block has a vertical speed, and by pressing A and D of the USB keyboard, we can horizontally move the red bar at the bottom to catch the green block. And the green block will bounce at the upper left and the right boundary of the screen, and we should prevent it to go to the lower boundary without bounce it at the red bar. And the fourth part is our difficulty system. There are totally 3 types of difficulty, and by pressing the button on the right side, we can change the difficulty 1, 2, and 3. Before the game starts, it will display on the 7-segment display, and there are also 3 LEDs corresponding to 3 levels of difficulty before the game starts. And now let's start the game. Okay, when the game starts, the 7-segment display will display other things, but the level of difficulty is still on the LED. And when we increase the difficulty, the green block will move quicker, and when the higher the difficulty is, the quicker the green block will move. And then we're going to talk about the 7-segment display. Before the game starts, it's a difficulty, and now let's start the game. After the game starts, the 2 bits on the right is a timing. It's a countdown from 30 seconds to 1 second to 0, and that's the total timing of the game. And the left 2 bits are the bonus points of the game. Let's see that. So we can see that there is a red bar at the top. If we go through that red bar, we will get some bonus points. And the longer the time that the red block is overlapping with the red bar at the top, the higher score we will have. So yeah, that's it. And when the time goes to 0, the game ends, and yes, it automatically ends. Okay, the goal of this game is to get a higher score by letting the green block to go to the top red bar. Now the game not start, so the top red bar is not displayed on the screen, but you know it's there. And in order to let the users to control where the green block goes, we have an algorithm to change the direction of the reflection angle of the green block when it bounces at the bottom red bar. So there are 3 situations totally. The first is that the red bar is not moving when the green bar bounces at the red bar. So the incidence angle is the same as the reflection angle. And for the second situation is that the red bar is moving in the opposite direction of the green bar. For example, the green bar is going to the left and the red bar is going to the right. So when they bounce, the horizontal speed of the green block will increase, and therefore the reflection angle will decrease. So the bar can change, and if they're in the same direction, the speed will decrease, and the angle can changes totally maximally 5 times. Red bar is not moving. The green block. Yeah, you can see that the incidence angle is the same as the reflection angle. This is the second situation. You can see that if their direction are different, the speed of the green block will slightly change, and the reflection angle will slightly decrease, and this can change for 5 times. Okay, and this is the third situation that they go in the same direction. You can see that the reflection angle will slightly increase. and the speed of it, and the vertical speed of the green block will slightly decrease, and so that the users can change the direction of the green block by doing this. Okay, there are two ways for the game to end. The first is as a green block goes to the bottom of the screen, I mean the lower boundary of the screen, without be caught by the red bar. Let's start the game. So die. And the second way for the game to end is that the 30-second countdown goes to 0. 5, 4, 3, 2, 1. And the green block will disappear and the goal will come back to the screen. And finally is to restart the game. We can restart the game by pressing button at the left side, and it goes back, then we can start again. Now let's have an overview of our code. So in the top module, combine, we have several important submodules. So there's clock divider, the modules to adjust the difficulty of the game, the module that is deciding whether the game is start or over, the VGA display, and the keyboard. And there is also a clock and the 7-segment display part. And now we're going to talk about them separately. Okay, I'm going to talk about the VGA module and the timing module. So for the VGA part, there are some very basic things like the clock divider, which divides the 100 megahertz clock to 25 megahertz, and the horizontal and the vertical counter. And what I think is special about our project is how the green block and the red block move. So so in this module, like here, this is a display, how we display the green block on the screen, and it's just to turn the green bits to 1. And down here, we have vertical speed and horizontal speed of the block. And we first calculate the speed to determine whether the speed is 1 or 0. So if the upper position of the block goes to the upper bound of the screen, the vertical speed is 1, and vice versa, and the same thing. And it's the same thing for the horizontal speed. And due to the speed of we calculated, we can now calculate the position of the green block. So it's like if the speed is 1, it will go up. There is an index that we will talk about later. And if it's 0, it will go down. And the same thing for the horizontal. So that's how the green block is naturally moving on the screen. And we did the same thing for the red bar at the bottom of the screen. And there is some input from the keyboard module. And when the keyboard input is something, it goes the boundary of the position of the red block goes to the left or to the right. So that's how we move things on for our game. And I also use the clock that we basically get it from the lab 4. So we commented out a lot of things, and we just left some parts that we need, which is to count down on the 7-segment display. So it's like for lab 4, we increment the value, and for this part, we just set an initial value to 30 seconds and then count down. And then there are other 7-segment display and binary to decimal part.
For how we implemented the angle change, you can see in this part, the horizontal and the vertical velocity of our green block are controlled separately, so we can change the ratio of the horizontal and vertical velocities to in order to change the angle of the square, the block's motion. And I also write a separate part to check if the direction of the keyboard output is the same as the movement of the blocks. So as you can see, the SD variable changes. The SD variable changes the block's velocity here, and the multi-2 change the uh, horizontal velocity. So if the direction are the same, like here, the SD variable will decrease, and if the directions are opposite to each other, the SD will increase. And also, we find when we integrate these functions together, we find that some timing issues are triggered, causing the motion of our block to become very unstable. And if we press it reset to, it will cause our board to disappear. Like our green block will change shape like slimes. So we eventually solved the problem by unifying the trigger, the sensitive condition of the always block, as you can see here. And also we removing some inputs of that had other timing controls. So eventually we solved that problems, and now it is all set.
Okay, so I'll talk about our keyboard module. So these are the keys that we originally want to take, but later we simply decide to take only two keys, like A and D, to control the left and right movement of the blocker, and because it will only like accept one signal at a time. And those are the codes that we use to handle the 8-bit code word like received by the PS2 port and convert it to a more readable like 4 bits for our later module. Also, I wrote the part of displaying some letters. We originally wants to make a universal system that works for any letter, but later we find out that we only need a couple of them, and we used to we think that we can use blocks to just make a roughly shape of those letters, and it's kind of brute force solution. So those are the squares that used to composite the final letter, and actually draw it on the paper and measure its dimension and enter it into this code. Okay.
So basically, there are three mechanisms designed by me. The first one is the button to control the difficulty. So it's here, a finite state machine. It is connected to a push button on the FPGA. So once you push the button, the difficulty will change from 1 to 3. So the difficulty is actually multiply one number in VGA to decide the speed of the block. So there are in total 3 different speed of that block. So another mechanism is start or not. So there is another finite state machine is connected to another push button on the FPGA. So when the button is pushed, the start change from 0 to 1, and it goes to this module. In this module, it combines with reset. So the with reset and the start is one is 0 and 1 separately. The difficulty will deliver to the VGA is and the difficulty will multiply to a number, and the speed of the block is decided. So if the start is not 1 is 0, which means the game is not start. The difficulty will not be normally delivered to VGA. Only 0 will be delivered to the VGA. So it's 0 multiply one number. The speed of the block is 0, so the game will not start. The third mechanism is the mechanism to counting the point. So there's a red bar in the demo. I think in the demo video on the upside of the screen. So it is displayed here. Let me see. So yeah, here is it. So this red bar, this is display module, and go to down here. This is to decide whether the green block confront with a red bar. So when the green block, the bound of the green block is inside the red bar, this point, eat apple, will increment itself. So this eat apple point will go to the 7-segment display and will be shown on the 7-segment display, the first 2 digital of 7-segment display. Okay, so this is my part. Thank you.